So am I able to answer your question?
यस सर, बस सर ये कंफ्यूजन था कि हमने एक्सपीएल से उसको कंपेयर करा था ना, अगर हम पीपीएल में कंपेयर करते हैं तो समझ में आ रहा है, पर एक्सपीएल से कंपेयर करने
Okay, so the thing is, like when you use XPL or the plane polarized light, why will it be different? If it's PPL or XPL, why will it be different? So for example, what we do in the plane polarized light, we use just only one polarizer, right? So in the XPL, we use the another set of polarizer, just the 90-degree with 90-degree angle with it. So all you are using is the optical waves, right? Hello.
यस सर।
So these optical waves, this will fall on your sample. If this is your stage, suppose this is your stage, and you are looking from somewhere here. So so like if you use, suppose you are not using this XPL, so you are not using this one, you are only using this one, so you will see something, right? Even then you will see some kind of heterogeneity, because you will see these biotites or muscovites with some kind of colors, and the quartz and feldspar, they are not of like they will be looking similar. If you use the XPL, then they will be different,
यस सर।
right? Yeah, so uh, like that's why uh, he probably have said that. So can I take more questions? I mean, if you have any more doubt, you can just throw them away.
Sir, in the second lecture, so sir has told some methods to study structural geology. So they are direct and indirect methods. So in direct methods, there's one geometric model, kinematic model, and mechanical model.
Yes.
And they in indirect it is analytical model. So could you please define what does indirect means here?
Okay, so suppose you are observing a structure like this. Suppose in the field or in the thin section, you are observing a structure like this. Okay, so what you will do in the geometric model, or if you are seeing a porphyroclast or something like that, this is a porphyroclast, and you are seeing the this tail of some newly recrystallized grains are following this. So from that, what we will try to do, you will try to, from the direct data, you will try to get like what is the rotation, what is the direction of rotation of this porphyroclast. So here it will be something like that. Here you can see there is a deformation in this direction. So this is a shear plane. So
Hello?
I close the whiteboard, right?
Yeah.
Okay, sorry about that. Yeah. So um,
No, that white ball is visible, but it isn't moving anything.
okay.
Everything is stagnant there.
See, you have to just maybe just bear with it, because I am new to these things. So is it visible now?
Yeah. Now it is visible.
Okay. So I am saying like if you have a structure like this in the field, suppose if you have a structure like this, then you will say, or maybe some kind of fault. Okay, so in direct method, what we do is, in direct method, we analyze these structures. We from the, or maybe from a thin section. People are want, they want to join. So Yeah. So if suppose in a thin section you are seeing a porphyroclast like this, so what you will do is from the direct method will analyze this rotation or maybe measure these things like what is the displacement here or here. So from that, or maybe if you have a thin section, from that you digitize this thin section, you want to calculate the shape preferred orientation or the grain size analysis, you can do the grain size. So these are the direct methods. So from indirect methods, what you do is like if you have some analog model of something, so you have to make some analog model of something. Say for example, have you heard about the sandbox?
Yes, sir.
Okay, so in sandbox modeling, what we do is we just we create layers of sands, and in the bottom part we just pull it with some kind of rotating mechanism. So when it pulls, it drags all the material on the top of it, and it will just build up, and it will produce some kind of thrust. So we study those things and relate that with, say for example, Himalaya or any kind of thrust fold belts. Okay, so
So
these.
analog and analytical modeling both are same things or they are different?
No, no, no. So the analytical modeling is when you are doing some analysis from that. So in kinematic modeling, what we do is, so in analytical modeling, what we do is there is two kind of things. Like one is the kinematic modeling, and one is the dynamic modeling.
Yeah,
So
yeah.
in the kinematic modeling, what we do is we do not consider the force, we do not consider the force, we just study their geometric relationships and all that. Say for example, if you are doing a stereographic projection, if you are plotting them on a map and getting out the you know mm, their geometric relationships, like how the folds are oriented, how the planes are oriented, like those kind of things go into the kinematic section. So in dynamic modeling, what we do is we use some kind of equation, some kind of continuity equation, maybe some kind of where we have to consider the force. Those are the dynamic modelings. Uh, am I able to clear your doubt?
Uh, so actually, the analytical modeling comes under the indirect methods.
Hmm.
So like analysis, I didn't got that. Like, what kind of analysis we do?
Uh, Maybe I am not getting your question. So can you wait for just another week, because I will go through the lecture then complete. Which lecture is it on?
Is it in second lecture?
Second lecture, sir.
Second lecture. Okay. So can we hold the doubt for 1 week maybe?
Sure,
Then I
sure.
will come back with the. I mean, what is he actually said? Then I will be able to answer your question.
Okay, okay. Thank you.
Okay. Yeah. So anyone else?
Actually, sir, I have wrote down some things from the lecture. So,
Okay.
sir has
Where is it in
told.
the chat?
No, no, no. Means I am making notes of the lectures. So, in a lateral modeling, we hypothesize a feature
Mm-hmm.
like that Himalayas has formed,
Mm-hmm.
prepare models, experiment based on the data collected from the field. So,
Mm-hmm.
these are the subscript from the lecture only.
Okay, so what part you are not able to understand? Like, suppose for Himalaya, we consider like for when we start, modeling Himalaya, we start with simple shapes. Like we do not consider, if we want to uh, understand how Himalaya has evolved, we start with simple plates, like simple geometry. So if suppose we will start with some kind of these rectangular blocks, so these are the two plates, maybe suppose plate A and plate B, and then we lock those boundaries somewhere here, maybe somewhere here, and we push it, or maybe we don't lock it because it has to roll, right? So maybe we lock it here somewhere, and we just use some kind of force to push it here, and when we study the interactions here. So these are the assumptions, like in specifically in art sciences, it is very difficult. Like there are lots of constraints, lots of parameters that we have to consider, and it will be very computationally, it will be very expensive if we consider all those parameters. So we always start with the simpler models, simpler geometry, simpler models, which at least represents some of its features.
Yeah, like the viscosity, like the density of the
Yeah, yeah, yeah.
material.
We will assume like the material will have, the material is homogeneous. Initially we will assume the material is homogeneous, then isotropic also, because we don't want the material to have a directional behavior, so it helps us to model the force fields and all these things. So after that we impose the complexities of the model. Then we maybe consider, we might have then considered like the material is anisotropic. Then we will maybe consider the heterogeneity and all those things.
Okay. Okay.
Okay.
Sir,
Yeah.
in isotopic structure, we have, for example, we have in a 1 meter square meter in different structure, stone structure, like black, white, and greenish. So,
Okay.
in that, that all one have a resistivity, conductivity as the same, or in three color coding is some different features.
What these colors, that red, black, and green,
Yeah,
what do they represent?
uh, it's a combination.
No, I mean those colors, they might have might represent something. So I am not getting your question. So could you please?
Okay, okay. In simplify, we have a one stone structure, stone, okay, granite or something.
Okay, suppose this is a granite block.
White, yeah.
Huh.
In that
Huh.
different particles is there in the when we have seeing cutting section.
Okay,
Uh,
so suppose.
one layer is black, one layer is white.
Okay, okay, okay.
Yeah.
So you want a layer structure, right? So it's a
Yes. Yes.
nice. Maybe that's a nice, right?
Yes. Yes.
Okay. So yeah, you have a layer like this, and you have a layer like this, something like that. You are saying,
Yes.
right?
Yes.
Yes. Yes. Now, could you please repeat your question?
Yeah, in that each layers have different tempo, electric conductivity and resistivity, or even all are the same.
Uh, so each layer is a different material. This is material A, this is material, different mineral. Say for example, this is mineral A, this is mineral B, this is mineral C. So as a whole, this mineral will have a different values of maybe conductivity, resistivity, and all those things. So this will be also different. But when we are measuring the bulk rock of if you are measuring the conductivity or resistivity of this rock, then you will get a different value. It depends on their orientation. I mean, how you are measuring. Like if you are measuring in this direction, the value will be different. If you are measuring in this direction, the value will be different. So if you are measuring the bulk rock, then the value will not be any of these values. It will be something different of the bulk rock. But if you are able to isolate this material, suppose if you are able to isolate this material, and if you're able to isolate this material A, B, and C, so, and if you measure the conductivity, resistivity, or any kind of physical property, maybe some strengths or something, they will show different value.
Okay.
Maybe they might show comparable value, but they are not dependent in any way. But
Okay.
when you are measuring the bulk rock, then
Yes.
they will not show any of these values of the individual layers values. It will show some kind of bulk conductivity, bulk resistivity, bulk strength, or something like that.
Okay. Okay. Right. Thank you, sir.
Welcome. So yeah, uh, anyone else?
Sir, uh, sir, I have little confusion about the structural elements that are used in structural geology. That what are the relationship between the structural element used in plane and structural elements used in line? I
Okay, so
mean,
you are
uh,
talking about deep strike, trend plants, this kind of things, right?
yes,
Okay, so you want me to explain what are these things?
yes, and also the relationship when they are equal, when they are different.
Okay, so actually I have prepared a slide for you, but it's I am not able to show you those slides, but I am trying to draw it again here. Okay, so
Okay,
just bear with it. So this is a plane. Suppose in a field, if you are measuring some kind of cystosity S1, and this is a plane, your plane of interest. Okay, so in this plane, you want to measure the deep and the strike. So strike is basically the angle of any horizontal line that will lie on that plane and between that line and the geographic north. So that is called strike. Are you able
okay,
to okay, so this line has to be horizontal. Okay, so definitely there will be a horizontal plane somewhere here. So this line has to lie on this plane and this plane as well. So the angle between the geographic north and the line, that will be the strike. Okay.
okay.
Okay, so
Sir, it's the line or angle itself.
angle, the angle between the geographic north and the line, the horizontal line, that is the strike.
Okay, sir.
Okay, yeah.
So can you
So
tell about rake and plunge?
yeah, I mean, it will be better if I go, step by step. I will answer the deep thing and then I will go with the trend and plunge. Is it all right?
Yes, sir.
Okay, so suppose,
Sir, it is better if you have some kind of notes or something like that.
yeah, I mean, there are lots of notes available in the internet. We can share it in the discussion forum if you want, or I can make one for you.
No,
If
no,
that,
no. I'm saying, sir, if there is a note and then you explain that thing, so that will be more better for visualization.
yeah, I mean, today it's not possible. I mean, something is happening with the share screen option. I don't know why I am not able to share my screen. So I have this OneNote file opened in my desktop, and but it's not. I'm not able to. So I'm trying to draw these things here. If you have any doubt, I mean, if you feel like you are not getting it, you can ask me. I don't have any problem, explaining it again and again. Is it all right?
Yes, sir.
Okay, so yeah, so we know the strike, and we want to measure the deep. So deep has basically two categories. One is called the true deep and the other is called the apparent deep. So when I say deep, most of the time we refer to the true deep. So what is the true dip of a plane? So suppose the plane is inclined in this direction. So this is the strike, it's not the other way, in this direction. So what we will do, we will consider a vertical line, vertical plane. Over the strike, we will consider a vertical plane, and on that vertical plane, the line which is making a 90 degree, which is the perpendicular with the strike, and it will be directing towards the slope of the plane, that is called the true dip. So this vertical plane has to be perpendicular to the strike. On that vertical plane, so the intersection of that vertical plane and the plane of measurement, so there will be a line, that will be a line, right? So two plane, when they intersect each other, they form a line, right?
Yes, sir.
Yes, so that is the true dip direction. Okay, that is the true dip direction. So this direction, if the projection of this line on the horizontal plane with the north, that is the true dip direction. And what is the true dip? So dip amount is basically the angle of this line and and another horizontal line which is lying on that same vertical plane. So this angle on this plane is the true dip amount. So dip means it has two parameters. One is the amount and the other is the direction. Am I clear?
Yes,
Hello?
sir.
Yes, sir.
If anyone has any doubt, you can ask. I will explain again. I guess you all understood. Now the thing is,
Yes, sir.
okay, so now the thing is, if this plane rotates, suppose this is not the perpendicular with the strike line, this plane is not, okay, someone, okay, yeah, so if this plane is not perpendicular to the strike line, if this plane, maybe we are measuring the dip at this direction, so that will be somewhat less than this amount. So the dip amount, if we measure not in the true dip direction by or any other direction, suppose can you see it?
Yes, sir.
Can you see it?
Yes, sir.
Okay, so
Yes, sir.
this is, suppose this is the strike and this is the true dip direction.
Yes, sir.
So the angle of the true dip amount will be the highest dip amount. I mean the amount of the true dip will be the highest in the true dip direction. So if you measure the dip in any direction other than the true dip direction, suppose you are measuring the dip in this direction, this is not the true dip direction, this is not perpendicular with the strike line. So if you are measuring the dip amount somewhere here, it will be less than this direction, true dip amount. Okay.
Okay.
Okay, so now trend and plunge, right? Suppose this is some kind of fold axis or Parker lineation or any kind of linear feature that you want to measure in the field. So what we will do, like the same thing, like with the strike direction, there will be one component that that we have to measure from the geographic north, and the other component we have to measure from the horizontal line, from the horizontal plane. So the, like with strike in the previous part, we measured the strike that has an some kind of angle with the geographic north. So here the angle will be called trend, and the true deep amount that we measured, that will be plunge. But you should not confuse with the strike and the trend, because the strike, what you will do is you will project the linear feature into some kind of horizontal plane. Suppose this is the horizontal plane and this is your projection on that horizontal plane. Okay, this is the original line, and on this horizontal plane, this is your projection. So the angle with the north, from the part it is tipping will be called trend, and the plunge will be, so with this horizontal projection and with this line, you have to draw a vertical plane or imagine a vertical plane. So this angle, that will be plunge. Am I clear? Hello?
Yes, sir.
Yes, sir.
Okay. So anything else?
हेलो सर.
Yeah.
सर आई कैन इन टॉक टू इन हिंदी. सर मुझे वो डायरेक्ट और इनडायरेक्ट डायरेक्ट मेथड है दोनों भी, जो 4 टाइप रहते वो पूरा समझा नहीं है अच्छे तरह से.
सॉरी, डायरेक्ट
ज्योमेट्रिक
मेथड, इनडायरेक्ट मेथड में
4 टाइप, जो ज्योमेट्रिक मॉडल, काइनेमेटिक मॉडल, मैकेनिकल मॉडल और एनालिटिकल मॉडल जो है ना सर, वो फिर एक बार रिटर्न करेंगे क्या सर?
Okay. So the thing is,
एक्सप्लेन
I have made a presentation actually. So I just, so someone asked me the same thing. So what I will do is, from the first 10 to 15 minutes, I am just noting these things down. So in the next week, I will, explain all those things in the first 10 or 15 minutes. Then we will have, that day's lecture. So the class might get a little bit extended for maybe half an hour, but that is okay, I think.
Okay.
Okay.
Okay, so yeah, I am like some kind of confusion is there with the indirect method and direct method and all these things. So I actually planned that, but it's okay. I will get back to you with this thing in the next week. Okay.
Okay sir.
Okay. So anything else? See, any kind of doubt you can ask, like any kind, how minor you think the doubt might be, you
सर
can. Yeah.
सर ब्रंटन कंपास के बारे में सर थोड़ा बता दीजिए.
Okay, so I need a Brunton compass for that. Can you just wait a bit? Tushar, are you here? Tushar, can you bring me one Brunton? Tushar, Brunton, huh? Okay, so I asked someone to bring the Brunton. So if he brings, then I will show you like what are the different parts of the Brunton. Maybe because you have the StereoNet lecture in the next week, right? So everything about measuring and all this in the week 2 lecture that is already uploaded, right?
So can you tell that how the homogeneity and heterogeneity is related to the function of scale?
Oh, okay. So क्लाइन है ठीक है चलेगा. Suppose this is a rock microstructure, this is a sandstone, so there is some kind of matrix here, some kind of cement, and these are all quartz. Let's make it simple first. Okay, so now you have a block of sandstone somewhere here. So how will you see this block? So what is the scale of this block? Suppose this block is a couple of centimeters wide. So for example, it's 40 centimeter wide. And here you are seeing, say for example, it's kind of 200 micron. So these two images, these two observations, they have different scale. Now, what will you see if you see this block? You will see that this block is more or less yellow in color, right? Sandstone, they appear to be more or less yellow. So it will be a, you will see that there is everything in this block is basically this. So any part, if you observe some part of it, if you observe, say, this part of it and this part of it, you won't find any difference. So you will see that the same yellow color, whichever is here, the same yellow color is what it will be here. And if you observe, if you measure some kind of property of this block from here or here, that will also be same. If you measure, like if the measurement, if there is coarse scale. But if you say, for example, here you are measuring, the reflectivity or some kind of things, maybe some, maybe the color, maybe resistivity, something you are measuring. And here, if you are, if you see this slide, this section, so the property of this part, this quartz grain, will be different from this part. Am I clear? What I am trying to say is the property of this grain, that will be different from whatever cement it has. Am I
So
clear?
we can say that homogeneity. Yes, sir. So we can say that the homogeneity is seen in a large scale.
Yeah. So homogeneity. So this rock is homogeneous in this scale, but it is not homogeneous in this scale.
Okay, sir.
Okay. So this is heterogeneous. Like the properties of this cement, that will be different from the properties of these quartz grains. And some quartz grains might have inclusion within it, and some quartz grains might not have any kind of inclusion. Okay, so this property is very much heterogeneous at a microscopic scale.
Yes, sir.
Okay. Yeah. So I was telling, like, if you want to go through the okay, so someone asked about the Brunton. So I don't have the Brunton right now. I have the clinometer. Is it okay if I show you the clinometer and how to operate it and all those things? Whoever asked this Brunton question, can you unmute yourself and
Yes, sir.
confirm? Okay, so can you see it, the clinometer?
Yes, sir.
Okay, so this is the bridge that we have. And so calorimeter is basically a special type of compass where you will get the direct reading. Suppose this is your plane. So what you will do is,
Sir,
yeah, hello,
I think sir this one is clinometer compass.
yes, this is
But
not Branton.
अच्छा सर अभी मतलब कंपेयर कर रहे हैं सर.
नहीं, मैं कंपेयर नहीं कर रहा हूँ. I don't have Branton with me right now.
Oh.
So maybe you will have to wait for a week so that I
Okay sir,
arrange a
नेक्स्ट
Branton.
टाइम देखूंगा ये
Sorry?
सर काइनोमीटर कंपास देखा है सर उसमें
Okay,
ब्रंटन.
so you want to know about Branton. Okay, so I will arrange one Branton. Those Branton and this indirect method, that is what we will start the next week. Okay, so we have 15 minutes more left of this class. If someone has any question, he or she should ask. Otherwise, I will tell something about the projection. What is the pseudographic projection, and how you should handle this kind of projections. I will tell a little bit about it. So if you have any question, anyone has any question?
No, sir.
Excuse me, sir.
Yeah.
Sir, actually, even I have a doubt regarding the Brunton compass. Sir,
Okay.
you can do this in like in next week, sir.
Yeah. I
Can
will
arrange.
arrange one Brunton compass, and I will tell like what are the different parts and how to measure.
Yes, sir. Basically, how to measure actually
Yes.
the thing. Thank you so
Yeah.
much.
Yes, it's all right. Oh, so there is one request that I want to make. Like, if any of you have not registered for the course, please do register for the course, because you will get a certificate for it, and this is a one of a kind course in art science that is being taught by Professor Shantanu Mishra. So if you register your course, you will only be beneficial. So kindly please register the course. Do not only join, because that certificate might come in handy. All right.
Sir, can you please tell about the scope after doing BSc with geology,
Okay. So
or what we
should
can
we?
do?
Yeah, should we do that now, or we can do it later? I mean, there is a vast spectrum of things that you can do actually when you study geology or earth science, especially if you master structural geology. There is a vast spectrum of things you can do. Firstly, you have to decide if you want to be academician or if you want to go in the service providing fields. That you have to decide. Then there is lots of opportunity, but I think we should dedicate one class for that, maybe not today. So
Yes, sir.
yeah, and yeah, if you do not have any more question, then I will go through a little bit about the projection thing. Is it all right?
Yes, sir.
Yes, sir.
Okay. So there are different kinds of projections that are available. So why is projection required for a structural geologist or any kind of any geologist? Is that suppose you are seeing a mountain or some kind of valley here in the field scale, and you want to take it on a piece of paper. So that will be your map. So there has to be some kind of equivalent or same procedure, so that someone who sees this mountain here and some other person if sees this mountain here, so they will produce the same map. so that everyone else, like, it's impossible for all of the people, to all the people to go somewhere and see all the features in the field. And then if you want to convey like the information that you got from the field through a paper, there's some kind of projection that you have to use. So people have come out with a very intelligent way of doing it. What they have done is they have connected the places where it has the same height. Okay, so these are called contours. So maybe this contour is 800 meter, maybe just assume this contour is 600 meter, this is 400 meter, so on and so forth. So when you and you plot those things and you project these contours on a horizontal plane. This is orthogonal projection I'm talking about. So when you plot those things on a horizontal plane, you will see some kind of circular kind of thing. You might have seen some kind of thing like that will appear, right? So in the map, you will see like there are some kind of circular things, some kind like that, and something like that, something like that. So each contour will have a particular value. Like this contour might have a value of 600 meter, this contour might have value of 800 meter. So from that you will know that this is a hill. And if the contour is, suppose if this is 400 meter, this contour is suppose if this is 400 meter, and this is again 200 meter, and this is 300, sorry 100, this is probably somewhere at sea level, then this will signify some kind of valley. So this is and the base level that is called the datum. So from the datum you have different kinds, you will get different kind of contours and you will produce some kind of map. Am I clear?
Yes, sir.
Okay, so this is all about the spatial disposition of structure. So suppose if a structure is somewhere here and another structure is somewhere here, if you want to know the spatial relationship of these two structures, then this map comes handy. But what if you want to know what is the angular relation with these within these two structures? Suppose you have some kind of fold here, some kind of fold here, and you have some kind of fold here. Okay, so and you want, and this mountain or the valley, they are produced at the same event. So you want to compare these two folds so that you can reach into any kind of conclusion. So what you will do is, for angular comparison there is a different method that is called, the projection method is different, that is called the stereographic projection. So in the stereographic projection you will be able to calculate their angular relationships. So in the stereographic projection, what you do is you assume that this is a sphere. It's a very bad sphere, but time being, please assume that this is a sphere, and a sphere will have one equatorial plane, that is the horizontal plane. So now imagine that there is a plane. So all the features that must go through the center of the sphere. So this plane will cut the sphere somewhere here. This is a plane. Say for example, any kind of bedding plane or any kind of planar feature. And this is the center. Are you getting it? This why this plane is looking like this? So it is the only portion of the plane that is inside the sphere. All right. Hello.
Yes, sir.
Okay, so now if you plot the if you project the perimeter or the edge of this part, you will get on the horizon, on the horizontal on the equatorial plane, you will get some kind of curved line. You might have seen this in the books or something, in books or any kind of lecture material. So there will be some kind of curved line, right? Hello.
Yes,
and
sir.
and these points, or they all should connect to the pole of the sphere. All right, so if I am just drawing this equatorial plane here, this is not the sphere, it is just the equatorial plane. So this will be the north, like this will be the north. Just imagine that the plane has a strike exactly 0 degree. So the plane will look something like this. So the plane will look something like this. So it has a strike of 0 degree and it has some amount of dip. So what they have done is they have divided this space from here to here. If you have, suppose if you have a multiple planes like this, so the plane that will be lying on the equatorial plane, what will be the dip amount of that plane? The plane that lying on the equatorial plane, what will be the dip amount? If the plane has a projection like this, what will be the dip amount? Can anyone tell? So the equatorial plane, I'll give you a clue. The equatorial plane is the horizontal plane. So what will be the dip amount of this plane?
So 0 degree.
Yes.
Zero. It will be
Yes,
zero.
yes, absolutely. So this will be 0 degree. And if one plane is vertical like this, what will be the dip amount of this plane? The projection will be, yes, 90 degree. Yeah. So the projection will be something like that. So they have graduated the space from here to here with 90 divisions. All right, you will have 90 such divisions where you can get, so that is the resolution of a stereographic net or the stereographic projection. Like suppose if a plane is dipping 25.4 degree, so you cannot plot that in the stereo net. You have to consider either 25 degree or 26 degree. You will obviously will consider 25 degree because this point is more closer to the 25 degree line. So imagine this is the 25 degree line. So your plane will be plotted somewhere here. Am I clear up to this point?
So can you please explain it again?
Okay, so what they have done is they have graduated the space, like a plane that will have a dip of 90 degree will plot somewhere here. The plane which has a dip of 0 degree will plot somewhere here, right? Hello, is that right?
Yes, sir. Yes,
Yes,
sir.
yes.
So any plane in between that, any plane that can have so or any possible orientation of that plane will have the value of 0 to 90 degree, right? It can have like 1 degree, 2 degree, 3 degree, like that. It can go 10 degree, 20 degree, 30 degree, 40 degree, 50 degree, and up to 90 degree. So all these planes will be plotted in this space. So a plane that has a 0 degree dip, that will be like this. So it will be plotted like this. If we increase the dip amount, say for example 30 degree, it will be plotted like this. If we increase the dip amount more, say for example 60 degree, it will be plotted like this. And if you have a plane that is dipping 90 degree, it will be plotted like this. Am I clear now?
Yes.
Okay. So this is how you plot a particular plane which on a stereo net which has a strike of 0 degree and a particular deep amount. Now if you want to if you want to have the strike to have some value, say for example 10 degree, I will upload or show you some kind of video that I want to record and show you how to plot these units on these things, because someone has already asked in the discussion forum about the plotting thing. So I'll just show you here. So suppose, and this is north, and so this circle will be graduated by 360 divisions. Okay, so this will be east 90 degree, this will be south 180 degree, this will be west 270 degree, and this will be again north 360 degree. So suppose your plane has a strike of 10 degree and a deep amount of 25 degree towards the east. Then your plane will look like this is the 10 degree strike. For example, your plane will look like somewhat like this. And this is a very high angle thing, so let's just ignore this. Yeah, so your plane will look somewhat like this, so all the elements that you plot that has some kind of angular relation that can be plotted within one stereo net, and you can calculate the angular relations in between them. So this is just to give you some kind of idea. I know that you have some couple of doubts about this thing. So far what I have explained is it clear to you all?
Yes, sir.
Yes, sir.
Okay, so I will like the next day I will start with the analytical thing and then Brunton, then maybe we will dive into this stereo net thing. Is it all right?
Okay, sir.
Yes,
Yes,
sir.
sir.
Okay, thank you very much for joining the session.
Thank you, sir.
Thank
So
you.
yeah,
Welcome.
we
Thank
will
you, sir.
see you. I will see you next week then. Okay.
Yes, sir.
Okay, I'm ending the session. Thank you.